She feels comfortable.
We are going to talk about the first derivative test. We're also going to talk about increasing and decreasing functions. And as I said, we've done this already. We took care of it on Tuesday, but we will review and use a couple more fancy terminologies, if that's a word. Okay, so we're going to talk about when an interval is increasing and decreasing. Fairly simple, increasing going up, decreasing going down. We're going to talk about the first derivative test. It's a test that uses the first derivative to find relative extrema. So one of the things we talked about on Tuesday was the fact that we were able to find critical numbers, but we didn't quite have a system in place for identifying those critical numbers as being relative maxima or relative minima. Today, the first derivative test will allow you to do that. And then, if you haven't already done so, you should compliment two strangers today. Okay? And not in a creepy way.
You look nice.
The person sitting next to you is not a stranger. Don't bother complimenting them.
I like your teeth. Smile.
They might be strange, but they're not strangers.
That was fun.
I'm so much.
Okay, so back to the hill. What do I mean by that? So we talked about Rolle's law or Rolle's theorem yesterday, which this hill would implement. But more importantly, what I want to talk about is when we hit that peak of the hill. Okay, so we start at level ground over here. Over there somewhere where you hit level ground. It's behind that other hill. Okay. So we hit the maximum of that hill, and I think looking at that picture, it should be obvious to you that we're dealing with a maximum. And what we talked about yesterday, I think it was Matthew that discussed this, we talked about what's true about the slope of the function, the slope of the tangent line to the function, to the left of that hill.
It's increasing.
No.
Positive.
The slope.
Positive.
Positive, correct. So the slope over on this left-hand side is positive. And as he just mentioned, the function is increasing. It's going up. That should be fairly logical. If you're climbing a hill, you have to go up to get to the top of the hill. Then you get to the top of the hill, and you start to come down. Matthew, the slope is... Ooh, that's a horrible color.
Negative.
Thank you. And the function is decreasing. You have to be careful with your terminology, okay? The function is increasing and decreasing. The slope of the tangent line is positive and negative. The function is not positive or negative. The slope of the tangent line is positive or negative. Do I have to go through the reverse if we're going into a pit? Or can you understand how this would be reversed? We're good. You don't need me to go over that. Excellent. That's the entire lesson. Okay. Now, I'm not done. No.
I was looking for the here and the.
Let me rephrase my statement. That's the gist of the entire lesson. Okay?
I always read it as here and this around.
Where's the function increasing or decreasing? So if we look at the picture again, it's obvious it's increasing when it's going up. But what we want to be able to do is pair up these two things. How are we going to know when the function is increasing? The function is going to be increasing when the slope of the tangent line is positive. How are we going to know when the function is decreasing? We pair these two puppies up. Slope of the function, the function is decreasing when the slope of the tangent line is negative. Which is what we get from that fancy schmancy stuff. Okay. Now, I don't even like this. I wouldn't even write it down. I'm just showing it to you because I feel obligated because this is the calculus speak. You take 2 points x and y. You take 2 points x1 and y1. It's going to be increasing if the y value gets bigger. It's going to be decreasing if the y value gets smaller. Okay, that doesn't make a lot of sense to me. That makes more sense. If it's going up, it's increasing. If it's going down, it's decreasing. The stuff in the blue rectangle, not very practical. The red stuff, I think, will make more sense. Okay? How are we doing so far? Easy peasy? Yeah? Good. this is really what I summarized on this picture. Okay, pairing those two things up is summarized in this fancy calculus speak. If the derivative of the function is positive, in other words, the slope of the tangent line is positive, then the function's increasing. If the derivative is less than 0, also known as negative, also known as the slope of the tangent line, then the function is decreasing. If it equals 0, it's constant. That constant can take two forms. It could be a maximum, like that hill. It could be a minimum, like the pit. Or it could just be a horizontal line. It is possible for a function to do something weird and then level out for a while. Most of the time, however, it's going to be a max or a min. Okay, so let's start with this function. We have a cubic because it's raised to the third power. We'd like to know where the critical numbers are. Take those critical numbers to figure out what happens to that function. Okay, so go ahead and find the critical numbers. I made an anti-faith slideshow. This is huge on Beautiful. Thank you. Hey, let's give it up for Hafiz. Nice. This is me being overly critical. I would maybe do this, just because we can. Okay, perfect. Critical numbers at 0 and 1. So what? So what's going to happen at x equals 0 or x equals 1? Or there's a weird third one. Could be a constant. Could be some weird cusp thing. For the most part, it's either going to be a max or a min. Okay, we'll get to that later. Right now, I just want to know what the function looks like. So I know, most of you know what a cubic looks something like that. Not always like that, but something like that. Which kind of fits in with our model here where we've got two critical numbers. So maybe one of them is here or one of them is there. Maybe it's flipped over. We need a way to organize. So the question is, what happens to the left of 0? Is the slope of the tangent line positive or negative? And how do we figure that out?
The slope is positive
Why?
because the line is curving like this. So
How do you know that though?
Oh, just from the picture.
So you cheated.
Yeah,
Or you trusted me that this is what it actually looks like.
I trusted you. Yeah.
Oh, that's a mistake. I lie like a rug. What if it doesn't look like that? Or what if it's a function that's so complicated you don't really know what it looks like? How do I know what happens to the left of 0? Right, so we got a thing here, and we got 0 over here, and we got 1 here. How do I know what happens over here? Mason.
You could plug in a value.
Good. What value would you like?
-1.
-1. If I plug -1 into this mess, let's go up here. actually, let's go here. This would be easier. If I plug -1 into this, will I get a positive or a negative value? Positive. It's a negative times a negative, so it would be positive. Okay, Mason, what's a good number to pick in, or what's a number to pick in here? A half. So if I put a half in here, this is going to be negative. This is going to be positive, so that's negative. And what would you like to pick over here? Let's get a little crazy. You feeling a little saucy? Let's. Oh, okay. I was going to throw out E, but I like pi. Okay. So if I put pi in there, will it be positive or negative?
Positive.
Positive. Good. Do we all agree? So, Conrad, did I end up lying to you, or did I tell you the truth? Does the graph really look like the way I drew it? Yeah. The function increases to some point, then it levels out and comes back to decreasing, and then turns and increases again. You did this in pre-calc, but what you didn't do in pre-calc, you struggled figuring out where those peaks and valleys were. You knew what the graph kind of looked like because you did nice things like quadratics and cubics. But you struggled to find those points. We won't struggle in here. Okay? Now, how do you answer the question? Where is it increasing and decreasing? You would use interval notation. Okay, let me clean this mess up. So the function was increasing when going from -infinity to, I forgot already, 0. For the negative infinity, parentheses or bracket? Always parentheses on infinity. What about 0? If 0 is one of those turning points we talked about on Tuesday, do I include it with a bracket? Or do I not include it with parentheses? Parentheses, why?
Because we don't know if it's a negative. How do you know if it should include it or not?
Well, that's what I'm asking. Should we or should we not? Luke, thoughts?
0 is not positive or negative, so it's neither one.
So you're going to say no.
So yeah.
So at the top of the hill, it's neither increasing nor decreasing, so we don't include it.
Yeah.
Is everybody buying into that? Great, let's go with it. Union, everybody forgets about the union symbol. 1 to infinity. Oh, that's a horrible infinity. I can't let that go. Oh, that's better. Decreasing from 0 to 1. Pretty easy, yes? Okay, good. Oh, look, I already did the work. Now, question?
Yeah, I just have a question. How did you get
The decreasing is where the slope of the tangent line was negative. So we tested 1/2 and the value was negative. So in that whole domain there, we know from 0 to 1, it will always be negative.
Oh, okay. And when you're testing it, you're putting it into the derivative right now.
Correct. Yeah, and that'll be explained a little bit more in a second. So I did this already, but what we would like to do is create a consistent method for us to check these things so that everybody's doing it the same way. And it's not all willy-nilly crazy. So we're going to use something called the first derivative number line. And I kind of did that, but I glanced over it because I wanted to go through the details here. This is very important. I drew a line, and I put f prime next to it. It's important for 2 reasons. Number 1, it tells you where you're putting points into to test. A common mistake is people plug values back into the original function. We don't want to do that. We want to put it into the derivative, which is what you just asked. Okay, good. Second thing, the reason it's there is because later on, we're going to do the second derivative test. And so you need to be able to distinguish between the number lines. Okay. Put the critical numbers on that number line. Remember from Tuesday, critical numbers are where the derivative equals 0 or where the derivative is undefined. Test regions, just like we did with Mason, and we get that picture. The arrows are important. They're important because they show you where it's increasing and decreasing, and it kind of gives you a general shape of the curve. If you, yeah. In case you didn't hear, I just got a ooh out of Molly. That's a general shape of a cubic. That'll become relevant when some of these functions that we start looking at you've never seen before. Quadratics, no problem. Cubics, a little bit of a challenge. Quartics, train wreck. There'll even be some really bad ones, but we'll save that for later. If you just look at that first derivative number line, what does it tell you about 0? What's happening at 0? Are you raising your pen, Atlas?
I guess.
Go ahead.
The slope changes from positive to negative.
Good. So what does that tell us about what's happening at 0?
It's a maximum.
Beautiful. And what's happening at 1?
It's a minimum.
Woohoo! Okay, you're like the class cheerleader today. Well, thanks. Appreciate it. So, the first derivative test is exactly what Atlas just explained. This is how we determine whether a critical number is a max, a min, or, unfortunately, sometimes neither. That's going to be scary, but we'll cross that bridge when we get to it. Okay, so we go back to this little function. There's a picture of it. So I did not lie to Conrad. I was honest, and that's what the shape looked like, and everything else fell into place like we expected it to. Increasing up to 0, decreasing to 1, increasing from 1 to infinity. The only thing I'm missing there are the arrowheads. Sorry. Okay, so the first derivative the first derivative test will tell us where the relative maxes and mins are. So this is the fancy edu speak, or calculus speak, for what we already knew. Critical numbers are determined where the first derivative is equal to 0 or where it does not exist. And then you've got 3 cases. If it goes from positive to negative, it's a max. If it goes from negative to positive, it's a min. And if it doesn't change, then it's neither. It's just some weirdness that happens. I'm just giving you time to write. It's not like I've gone to my happy place or anything. Not a local extreme. Now, before I go any further, does this make sense? Yes or no? Okay, good. So I'm hoping that the concept is more important than the application. The application is actually pretty easy, but the concept of what you're doing with that application is much more important. And we're going to do this ad nauseum, unfortunately. This is a really, really crucial part of calculus. You know the term ad nauseum, right? Okay, good. If it goes up, then comes down, it's a max. If it goes down, then comes up, it's a max. All right, let's do it. We got a cubic again. You can pretty much guess what's going to happen, but I might have picked an interesting function that does something weird. What I would like to know is, where are the relative extrema, and what kind of extrema are they? Is it a max, or is it a min?
You scream, "Crap hockey" in the face, and then give you some food.
Sure, we can't do that.
That's what I was told. You only did before the
So I'm honored to be in the presence of a Chick-fil-A VIP. Uh-huh. I'm not sure what's going on there.
You see that right already?
minus
Math that you worked up.
If you're a little sketchy on factoring, just fire up your quadratic formula on your calculator. I mean, it's kind of cheating, but that's okay. I won't tell if you won't.
Critical numbers there? Okay, cool.
Does it not factor easily?
Oh, it factors.
You made me think it was I was like, I have to
Quadratic formula on your calculator. Don't do. Oh no.
It's okay.
Oh, hold on.
So sad. So ugly.
Oh wait, that's an empty goal page. That was
That
was a jerk move.
so rude.
There you go. Wouldn't that be nice if you actually had some tape?
This is from Target.
My daughter works for Target.
What? Which one? She looked at the one in Arlington Heights. I'm gonna go there.
She works at Target corporate.
She's like corporate.
Yeah, she's not like a cashier.
Oh, okay.
She works in a big scary office and makes big decisions.
I'm going to Target after school. If
She's actually in charge of ordering pies for the entire country. Yeah, they call her the pie queen. She decides how many pies each Target in the country gets.
Could she give extra pies to our Target?
I don't know. I'll ask her.
What pie does she like?
I don't think she can eat pies anymore because of this job.
She's like, because I can eat pie. Like, if I go to her favorite Target, and like they were the most.
Well, she does that. When she comes into town, we go to Target. She's like, oh yeah, I ordered those. Yeah, I ordered those too. The guy that orders those is a jerk. What do you want?
I'm having a head problem. Why did I think I had used the
Because he mentioned it.
I was like, I have the wrong number.
Did you factor it? I did. What did you get for your critical number? 1 and -5.
That's what I got too. Wait, guys, so did I.
Whoa!
Yeah, we're so smart.
Why is it up there? Why did it do that?
What's the matter? You gotta make sure your sleeve doesn't touch.
What?
Huh?
I didn't touch it.
I know
My
what your
sleeve didn't touch it. No,
There
it
you go.
didn't.
The elbow high. Right,
That's
drink
so
your tea
strange.
with
With the
the queen. No, that's
queen,
pinky high, not elbow. You don't
With the
drink tea like this.
I think that would be kind of awkward, not gonna lie.
I don't know where I go.
The number line.
That was not the right.
So like it's literally the exact thing you just learned and I just did not remember it. I love when I'm smart.
-5 of those. Some weird habits. 0. So we have something. Oh wait, I got positive. Yeah. Okay, so we said that we don't break it 5
Combination of all of this stuff, and he was drawing incredible.
Well, you have to do something. Oh.
Well, I mean, I'm not talking about science. Something that doesn't.
I was just I did. I saw it as soon as you walked in. I was like, oh my gosh.
That was not long enough.
-6 plus 5.
Told you, sleevage. There you go.
It's okay, I figured it out. So then, do I have to like do it on the board, the testing, or can I just write what I got?
You can just write what you got.
Okay.
Talk us through it. We're doing it here. When they look through it.
I don't know what my time is.
I was trying to be participating.
I know you were trying. You did great. I think that's your best conversation. I just for context, because he had mentioned that his daughter lives like in Minneapolis, and that's one of the corporate or like whatever 500. What's it called? I'm not throwing a whatever 500. Fortune 500.
Okay, so Atlas did all the work, but neglected to answer the question.
The relative, because the maximum end.
Yeah, where's the maximum?
Max is -5/3.
Good, as my grandfather would say, -5/3. Okay, and?
Min is 1.
Good. So that's really what we're looking for. We got a bonus with the increasing and decreasing.
Yeah.
Wasn't needed, but good.
Do you want me to go put max and min on the board?
Nope, because my next slide will explain all about it. The question though, coming back to you, Atlas, how do you know that -5/3 is a max?
Because it first like increases and then decreases.
Okay, now, one thing you need to be aware of for everybody, pronouns are bad. When you say it, I don't know if it is the function, the derivative, your pet dog, whatever. So we want to be very specific, so say it again.
The derivative goes from a positive slope to a negative.
Good. There's two ways to answer that question. One way is exactly what Atlas just said, and that is the function goes from a positive slope, the derivative goes from a positive slope to a negative slope. The other thing is you could talk about the function itself. The function goes from increasing to decreasing. What you can't do is confuse those two. The function is increasing, the derivative is positive. Because that becomes confusing, and because the College Board can sometimes be a little persnickety, we will click over to here and talk about writing a sentence. We're going to try to be consistent. And so when you're done and you find your max or your min, you're going to write a sentence. And the sentence looks something like these two. A relative max occurs at x equals 1 because f prime changes from negative to positive. Relative max occurs at x equals -5/3 because f prime changes from positive to negative. Now I would put a sidebar in here. You could say because f changes from decreasing to increasing, or f changes from positive to, no. Come on, Reedy, you're better than this. From increasing to decreasing. However, I like the blue better because you're already going to create a first derivative number line, so stay with the first derivative through a lot of your discussions. It makes it easier to put together. Unfortunately, you're going to write that sentence so many times you're going to come to hate it. But it is an important part of doing this kind of work of finding relative max and relative min. Okay? Questions? Not so bad? Si, señorita.
So when we write, is this our only answer, or do we also have to put it in a point or something?
You would combine this work.
Okay.
Shy of, you don't need this.
Okay.
This work combined with your sentence.
And that's it.
Right.
Okay. Thank you.
Now, one thing Atlas asked that I didn't address is, do you need to show the work of testing values? No. Okay, so how do I know you tested the values? I don't. Now, and I'll also warn you that a common mistake that people make early on is they test the first region. What number did you put in to the left of -5/3?
-2.
-2. They'll get an answer and then they'll assume it's going to go positive, negative, all the way down. Okay, that's not going to happen. It probably happened a lot in pre-calc. It's not going to happen as often in here. So you need to test every region. Also, make sure you pick a number in the region. Okay, -5/3 is -1 2/3. Don't choose -1 to test the far left region. If you're not sure, put in a negative gabillion. If I put in a negative gabillion, this is going to be negative, that's going to be negative, therefore your answer is positive. Okay? In the middle region, make sure you pick a number in between negative 5/3 and 1. What's a good number to pick in there? 0 works really well. And then when you go to the right of 1, pick a number that's you're sure is to the right of 1. Okay? Okay, one more for you. Go. I chose this one for a reason. I want to see how you take the derivative of that bad boy. Because there are a couple different ways to do it.
This makes me want to cry.
I think I'm going to go bottom. I think that's what I'm doing.
Yeah, what are you doing?
Is that 1/3 or 1/3?
1/8. It's 1/8. I think you should put 1/8.
That's a dummy.
Some people try and hack me, and I don't appreciate it.
I don't know what you're talking about.
As long as you get the right answer. Mason, what'd you do? Product rule? These are numbers. These are parts of numbers, 25. Victor, what'd you do? Product rule? Okay. What we got over here? Product rule. Why does that work yet? I didn't know they did use this. You don't, you try to get a lot of.
No, but like, you don't have to.
I did it, I didn't know how you guys did it.
Yeah, you have to do it. Just product rule. Just product rule. Product rule. Remember, the next is over there.
I got
Minus
it. I had to go.
What do we do? Product rule? Product rule.
I got this.
Yeah, I got that.
Oh,
Yes, you did.
good job.
I don't think it's right. Maybe it is.
Maybe.
I didn't do a
But,
product rule.
okay, negative x.
What'd you do?
Something else.
This is.
She did product rule. Check what she did.
3x minus 1 is
You would look for the electric. That's how I.
because it's x times negative x times x. That's, you have to add 1 and
1. Oh, it's 1.
I don't
20 of you.
know. I have
So you know how you said that?
Yeah, yes. That makes sense.
Yes, 1/3, yes.
All right, so 20 of you did product rule, which is fine. 2 of you distributed. For those of you that did product rule, you might realize that that might be a better way to go, but doesn't have to be. Luke, when I do the distributive property here, I can handle the first one. I'm a little shaky on the second term.
It's x to the 4/3.
It's what?
X to the 4/3.
This?
Yes.
Why?
Because the exponent's at.
What exponent? There's no exponent here.
Well, that's like the same thing as 3/3.
Oh, I get it. Okay, then you added 1/3 plus 3/3. Okay, good, thanks. Everybody good?
Yeah.
I'm going to continue with this. Is that okay? Yeah, good. F prime of x is equal to 8 thirds x to the negative 2 thirds minus 4 thirds times x to the 1 third. Okay? Am I good? Am I good so far? Okay, good. That's a, no, that's not a sum. What is that called? That's a difference. Difference no good. I need a product because I want to be able to test regions and find critical numbers, set it equal to 0, do all that fun stuff. So I have to factor out a common term here. I am going to factor out a 4/3 x to the, and you'll remember way back when we started simplifying functions, I made a point of giving you a rule. This is where that rule becomes important. What is the rule? More negative exponent. So I'm going to factor out a negative 2/3. If I take a 4/3 x to the negative 2/3 out of the first term, I leave a 2 behind. If I take a 4/3 x to the negative 2/3 out of the second term, I leave an x behind. Well, that's just lovely. That worked out really nice. Now I set it equal to 0. Critical numbers. X equals. Where are my critical numbers? Zero and 2. Does everybody understand where the 0 came from?
Yeah.
Okay. 4/3 x to the negative 2/3, you'll recall, moves that exponent to the bottom. Of those two critical numbers, you have to remember we're looking for things that make it equal to 0 and things that make it undefined. 0 makes that function undefined, so it becomes a critical number. Are we good to go so far?
Yeah.
Hot diggity. First derivative number line. Please, when you graph numbers on a number line, graph them in the proper numerical order. It happens all the time. Maybe it would be easier if I wrote it this way. 4/3 the cubic root of x squared times 2 minus x. Okay, let's do it that way. Now, we're going to make our lives a lot easier. 4/3 x to the negative 2/3. What can you tell me about that value when I start plugging numbers into it? Nothing? That's okay. Let's start plugging numbers. Smitty, what number would you like to check to the left of 0?
-1.
-1. If I put -1 in here, this would be 2 minus -1. That's positive. What happens to this?
It's just 4/3.
Well, all we care is positive or negative.
Positive?
Positive. Positive. Increasing. That's supposed to be, that looks like a 4. Hold on. I can't let it go. Let me go back to my question before. What's true about that?
It's always going to be positive.
It's always going to be positive. So that's going to make my life a lot easier testing values, because now all I need to do is test what's happening over here with the 2 minus x. Adrian, what number would you like to test between 0 and 2?
I feel like 1 would be the best.
1 is, well, I don't know best, but it's a solid choice.
Yeah.
Right. If I put 1 in there, is it positive or negative?
Positive.
Positive. Ooh. Ooh. One of two things just happened. I screwed up, or I didn't. We'll talk about didn't in a second. Adrian,
Yes.
what number? What number would you like to test to the right of 2?
Let's do 600.
Wow, somebody brought their big boy pants today. 2 minus 600, is that positive or negative?
I think that maybe, negative.
And you did that without a calculator? I'm so proud.
Thank you.
Good job.
Woo! Okay, let's move forward assuming that we did it correctly. What can you tell me? We'll do the easy one first. What can you tell me about what happens at 2? It's a relative maximum, correct. We'll write a sentence in a second. What happens at 0? I don't know. I don't care. So, a relative max occurs at x equals d because, and please write out the word because. Don't write B-E-C-U-Z. Some of you were thinking of what? Or B/C. Yeah, don't do that. Write out the word because. Because f prime changes from positive to negative. Done. Now, just for giggles, get out your Desmos or your calculator, graph that function to see what it looks like. In particular, what the heck is happening at 0? By the way, for reference, I prefer Desmos when we're doing something like this because you can zoom in and zoom out very easily. But if you want to use your calculator, that's what makes this such a great country.
You're gonna have to leave. I feel like you're bullying him and making him feel
Oh, I do.
She's like bullying.
Gets him closer to sucking her soul out.
You have to be nice to her. Take her on his face. Shoot it. That should roll murder on it. She's so scared. Murder. Oh, there's a jump. He's still alive though. That was my guess. Look at his little tail. I think his face off. You should get work done. Get plastic surgery. Fix your butt. Fix your butt. I can't feel my leg right now. It's like when you're. It's all good.
So the graph looks something like that, which fits our findings and also shows you that, well, what's so strange about what happens at 0? There's nothing there, but something obviously is there because 0 came up as a critical number. We'll talk more about that in the future, and in fact, when we get to the second derivative test, and we talk about concavity, that will help us explain what's happening at 0. But for now, all we need to know is that is neither a max nor a min. How many times do you work the word nor into a conversation? You're welcome. Problems? We're done. That, by the way, is a picture of a unit circle cake that somebody baked for me one time at our 100-day celebration. So the question you should ask me is, no, what's the 100-day celebration?
Yeah, what is that?
You will notice that our days in this class continue going on and we're counting up from 28. We used to do the 100-day celebration like kindergarten. Remember that in kindergarten? Yeah, the problem is we don't have 100 days. So we're going to do the 50-day celebration. So when the 50th day of calculus comes along, we'll figure out how to have a party of some type. I don't know.
80 minutes.
I don't know.
Everyone gets
I don't know what we can do.
replicas of this.
What?
Make a giant life size version.
What if we got like a cake that would work?
Oh yeah. I know what you can do.
Yeah, we should order